Hi, good afternoon, everyone. But in the last class, we had gone ahead and we had started talking about the P test, also called as P series test. Today, we are going to go ahead and we are going to take the other important tests that can be asked from series. The first test that we have, that is basically called as a comparison test, right? What do we do in comparison test? In comparison test, what we go ahead and what we do is we take two series. So one series can be called as submission UN and other series can be called as submission VN. If the UN term is less than the VN term, this is a bigger series. Its nth term is bigger than the nth term of this term, of this series. Then we go ahead and we can say that if Vn, the bigger series, will converge, then the smaller series will automatically converge. Automatically converge. And if the smaller one itself is diverging, so if UN will diverge, तो बेटा अगर छोटा वाला ही diverge कर रहा है तो bigger has to diverge. So Vn will automatically diverge. So if bigger is converging, smaller will definitely converge. If smaller is diverging, bigger will automatically diverge. But if the bigger is diverging, then we don't know what will happen to smaller. ऐसा हो सकता है ना कि बड़ा वाला series तो it is diverging to infinity, but smaller one can converge. So we cannot say what will happen in this case. So if bigger is diverging, we don't know how smaller will act. Similarly, if smaller is converging, doesn't mean bigger will converge. Bigger ka act we don't know. Right? So we can only say that if bigger one converges, अगर बहुत बड़ा series converge कर रहा है, तो उसका जो छोटा वाला series होगा, that will also automatically converge. और अगर छोटे वाला ही diverge कर रहा है, the smaller one is diverging, so the bigger one will automatically diverge. This is basically the the test that we go ahead and apply. ठीक है? Let us try to go ahead and let us try to read the official definition or the interpretation of this test. So submission UN and submission V, submission U and submission V are two series of positive terms. There exists natural number m such that UM is less than k times V. तो हमने UM एक mth term निकाला series U का, and we are saying it is less than some scalar quantity into V. That k can be 1 also, right? K being fixed positive number. Then when the smaller one converges, the smaller one will converge if bigger converges, and the bigger will diverge if the smaller diverges. Let us try to go ahead and let us try to take some example of this test. Okay. So example number 1, beta, we have sine n by n square. So we know that if I go ahead and I do sine n, we know sine n lies between -1 and 1. So if I do sine n by n square, it will lie between -1 by n square and 1 by n square. Now you need to go ahead and you need to try to understand this thing, that this can be my un, जो यहाँ पे ये term दिया हुआ है, and this can be my vn, right? This can be my un and this can be my vn. Now we need to understand how this vn is acting, right? So if I do limit n tends to infinity 1 by n square, how vn is acting? So we know that using p test, the power is greater than 1. Therefore, we know that it is going to be a convergent series. It's going to be a convergent series. So the bigger one is converging. So if the bigger one is converging, then the smaller one will automatically converge. So the smaller one will automatically converge because the bigger one is converging. And this is what this test is all about, right? So if the bigger one is converging, the smaller one will automatically converge. Okay. Keep all these tests in mind. Towards the end of class, I will give miscellaneous questions. माने उसमें कोई भी test इनमें से use हो सकता है. So you need to keep all the tests in mind together. Now the next one that we have, that is called as limit comparison test. So what limit comparison test is saying is the following. Let me just explain first. So again, I have two series, summation U and summation V. What I will do is, I will find the nth term of this series, the nth term of this series, and I will say limit n tends to infinity. And if this is some constant, ठीक है, माने I am going ahead and I am finding the ratio of nth term of series U and series V. And if it is coming out to be some constant which is not equal to 0, the constant is not equal to 0, then we will go ahead and we will say that both these series will, let me create some space, will behave similar. ये नहीं कह रहे हैं कि दोनों सीरीज, मतलब अगर इफ यू गेट द रेशियो टू बी अ फाइनाइट नंबर देन दे विल कन्वर्ज, ये नहीं कह रहे हैं. We are saying that if you get a finite number, then both the series, they will behave in the similar way, right? What is the meaning of behaving in the similar way? Behaving in similar way basically goes ahead and means that when summation U converges, then summation V also converges, or vice versa. And if one diverges, then other also diverges. So they behave in similar manner if when you find the ratio of their nth term, it comes out to be a constant L. Okay, let's try to read it out. Let summation U and summation V be two series of positive real number, and summation and un by vn is coming out to be L, and this L is non-zero finite number. ये एक L जो है वो non-zero, it has to be non-zero, remember, huh? Finite number. Then both series will act similarly, माने they will converge or diverge together. That is what we are going ahead and we are saying in this test, limit comparison test. ठीक है, let us try to go ahead and let us try to take some examples of limit comparison test. तो पहला example है what to do with this kind of series, summation n from 1 to infinity 1 upon n plus 1. Now अगर if I go ahead and I take this as this, so beta I need some vn also. Vn can easily be formulated by taking away the constants. So I can take Vn to be 1 by n. Okay. Now if I go ahead and I do Un by Vn, limit n tends to infinity, this will be limit n tends to infinity 1 upon n plus 1 divided by 1 upon n. So here I will get limit n tends to infinity n upon n plus 1. And this will give me limit n tends to infinity dividing both numerator and denominator with n. And this will give me 1 upon 1 plus 1 by infinity. 1 upon 1 plus anything by infinity is 0. That means 1, which is non-zero. So, mane, I have got a limit L, and this limit L that I have got, that limit L is a non-zero number. Now, once I get that this limit L is a non-zero number, what I need to go ahead and what I need to do is that I need to act. I know that these two series act in similar way. So I need to go ahead and check the behavior of this series Vn. So I can comment on the behavior of Un. And I know using p-test, summation 1 by n diverges. And power is 1. It is less than equal to 1, it will diverge. So this diverges, right? So therefore, summation u will also diverge. माने ये जो सीरीज हमने यहाँ पे लिया है, this should also diverge, right? Okay, let us go ahead and let us take one more example here. So here the example is summation 1 by n square plus n. Okay. So I am taking my un as 1 upon n square plus n. So the first thing that I require here to be done is to create vn. Okay. What I can do is I can go ahead and I can take vn to be 1 by highest power n square. इसमें थोड़ा सा आपको सोचना पड़ेगा कि what un by vn you will take so that the limit comes out to be a constant. आपको limit constant चाहिए. So limit n tends to infinity, un by vn will be 1 upon n square plus n upon 1 upon n square. It will be n square upon n square plus n. So you can divide both numerator and denominator by the highest power. So limit n tends to infinity, 1 upon 1 plus 1 by n. This will give me 1 upon 1 plus 1 by infinity, 1 upon 1 plus 0, which will be 1, which is not equal to 0. So I have got a non-zero finite limit. I have got a non-zero finite limit. Vn has to be greater than un? Not necessarily, no. There is no such rule here. Just that when we find un by vn should give me a finite number. This rule does not require any, it does not require any such relation such that greater than or less than. It was the other one which required that. Here, I just want this L to be finite. That's it. Okay. So now here we go ahead and we get that this is a non-zero finite limit. Therefore, un summation u and summation v, they will act similarly, right? And what is summation v? Summation v is 1 by n square. And we know that using p-test, because the power is greater than 1, it converges. So if this converges, then we know that both will act similarly. So this un, it should also converge. Un should also converge. So we can go ahead and we can say that it will go ahead and it will